Hey guys, Mr. Yeisley here. So we're on to lesson number 7 in chapter 6, all about factoring. And so in the lesson previous, we learned about factoring out a common binomial factor. And we're going to still use that technique in this next part, but we kind of have a starting point to get to there first. Once we're there, you should know how to simplify. So how do we get to that step? And that's what we're going to learn about, which is called factoring by grouping. All right, and grouping means we're just going to group some stuff together. And what we do is we group the first two terms. All right, we're going to group the first two terms. All right, first two terms. And then we're going to group the second two terms. Or you could say first and last, either one. All right. Now, in order to do that, all right, our whole goal then, once we've grouped them, is to factor out the greatest common factor. So we're going to have two terms, and we want to factor out the greatest common factor of those two terms, which you've already learned how to do. We learned about that previous in the chapter, so you know how to do that. All right. Now, sometimes in order to make that happen, to actually have a greatest common factor other than 1, not that you can't do it with 1, but we'd like it to be something other than 1, we might have to rearrange the order. All right. So this is where we do a quick check to say, hey, do the first two terms have a greatest common factor other than 1? Yeah. Do the second two? Yeah. We'll leave it as it is. If the answer to one or both of those is no, then we're going to rearrange the order to make it where it does have a greatest common factor. Now, once we've factored out the greatest common factor of each set of the groupings, which we should have 2 groupings exactly, then we're going to go into factoring out a common binomial factor, and we'll finish just like we learned about in lesson number 6. All right, so let's take a look at what this looks like in action. So example A, I have 4 terms, and in order for grouping to take place, you must have 4 terms exactly. All right, it must be 4 terms exactly. You cannot have 5 terms, you cannot have 6, you cannot have 3. You must have 4 terms. So if you don't have 4 terms, then grouping is not a valid method for you. But if we have 4 terms, then grouping could potentially work for us. So again, example A, I've got x to the third plus 3x squared plus 2x plus 6. So the first thing I want to do is I want to check, do my first 2 terms, x to the third plus 3x squared, have something in common other than the number 1? It could just be a variable, it could be a number and a variable. Any of that is fine, but we got to have something in common other than 1. Well, yeah, they do. They both have multiple x's in common. So I'm good there. Those have a greatest common factor other than 1. So then I look at the second 2 terms, so 2x and 6. Do they have something in common other than 1? Well, yeah, I can see that they both have a common thing of 2 in them, so I can go right into grouping. And so the way we do grouping is we put parentheses around the first 2 terms. Then we put parentheses around the second 2 terms, including this sign right here that's on what would be the third term in the order. We also include that sign, and that's important, and I'll tell you why here in a minute. Now, once we've grouped them, then we're going to factor out the greatest common factor of each grouping. So x to the third plus 3x squared. I'm looking for the greatest common factor. Well, number-wise, that would just be 1 because the coefficient of x to the third is 1, so I'm not so worried about that. But I see that they have multiple x's. X to the third has 3 x's, and x squared has 2. So the greatest common factor would be 2 x's, or x squared. Now, if it helps you to continue making the list like we learned about in lessons 1 through 5, then please do that, right? But if you feel comfortable at this point going through and finding that greatest common factor without the list, then now we can start to do that. So once I've factored out x squared, I go right back to like we learned about in lessons 4 and 5 of, all right, well, what did I multiply x squared by to get to x to the third? Well, I multiplied x squared by x to get to x to the third. Well, what did I multiply x squared by to get to positive 3x squared? Well, that would just be positive 3. So now I've factored out the greatest common factor of my first grouping. So now I need to do it in my second grouping. Right? So I'm looking at these two terms, 2x and 6, and saying, well, what is the greatest common factor? Well, not both of them have x's, so it can't be an x, right? But both do have numbers, and the greatest common factor of 2 and 6 is 2. Now, I need to state if that is a positive 2 or a negative 2. And in this case, because my lead term is positive, it is going to be a positive 2. So I'm going to put plus 2, and I need that positive sign there. That's a requirement, even if it's positive. So then I go, okay, well, just like before, what did I multiply positive 2 by to get to positive 2x? Well, that would just be x. Well, now what did I multiply positive 2 by to get to positive 3, or positive 6? Well, I just gave the answer away. That is positive 3. Now, if we have done our groupings correctly, 1, this should look exactly like where we started on lesson number 6, on each problem, what it looked like, right? Which means that the binomial in parentheses should be the exact same, x plus 3 and x plus 3, which it is, which means we did this correctly. So my first factor, or first parenthesis, is x plus 3. My second parenthesis is what's left over, x squared plus 2. So x squared plus 2, and that is my second factor. Now this last part that we just did is exactly what we learned about in lesson number 6. So if you remember lesson number 6, then you should be able to finish out the problem correctly. The big thing is making sure your groupings work and that you factored out the correct greatest common factor. If you did it correctly, you should always end up with the same thing here as here. If you didn't, then you can't go on to the last part of it. That's not possible. These have to be the same, right? And if they are not the same, then go back and check your work because something went wrong. Or it may turn out that it's not factorable altogether, right? Which is a possibility as well. But always go back and check your work if these two things are not the same. All right, well, that was an extended process to go through example A. We're going to move a little quicker through example B, C, and D. So example B, we've got x squared plus y plus x plus xy. So now when I look at this, I again check the first two terms. Do they have a greatest common factor other than 1? Well, both of them's number is 1, so it needs to be a variable. Well, this is x squared and this is y, so those are not in common. So it really doesn't matter if the second two have a greatest common factor because my first two don't, and so I want to rearrange this expression. So when I'm looking at rearranging, I want to make sure that both groupings are going to end up with something in common. And what I recognize is that if I group these x's right here together, my x squareds and my x's here, all right, that's going to then group these two together, and they have something in common. They both have y's in common. So that would be a valid way of rearranging. So I'm going to move every term into its appropriate place with the sign in front of it. So I've got x squared here. I'm going to move this positive x after it, which then is going to move my positive y behind it, and then my positive xy behind that. So I just rearranged to make sure both of my groupings are going to have a greatest common factor other than 1, which they do. So now I can group them up like I did before, remembering that the first term in my second grouping includes the sign in front of it. It's got to have that, and we'll get to that later on exactly why. It deals more with when there's negatives, but the positives are important too because that tells you what you're doing here as we talked about. So now I've got x squared plus x. What's my greatest common factor? Well, that would be x. So what does that leave me with? Well, what did I multiply x by to get to x squared? That would be x. What did I multiply x by to get to positive x? Well, that would be positive 1. So there's the first one. Now again, if we've done this correctly on the second one, we should end up with the same thing here. So then what's my greatest common factor of positive y and positive xy? Well, the thing they have in common is positive y. So then what did I multiply positive y by to get to positive y? Well, the only thing you can multiply something by to get to the same thing it already is 1. And what did I multiply y by to get to positive xy? Well, that would be positive x. So there we go. Now again, if we've done this correctly, the two parentheses should be the same. And when we look at them initially, they don't appear to be the same. One says x plus 1, and one says 1 plus x. Now, if we really think about that, is that the same? X plus 1, let's just say the number was 3, right, for x. If I did 3 plus 1, I'd get 4. Now, if I did that same thing and plugged 3 in for x here, 1 plus 3 is also 4. So these are the same thing, they're just written in different order. So even though they didn't come out looking exactly the same, they are the exact same. So we're going to choose a way to write it. I'm going to choose to write it as x plus 1 because I like my constants to always be at the end, so I'm in descending exponent order. Then I'm going to create my second parenthesis by grouping up what's left, which is x plus y. So my final answer is x plus 1 times x plus y. All right, well now I would encourage you to try example C on your own, then check your answer with mine. So example C, I've got a to the third plus 3a squared plus a plus 3. So again, I want to look at my groupings, make sure they make sense and I don't need to rearrange. So a to the third plus 3a squared, does that have something in common other than 1? Well, yeah, it does. It's got multiple a's in common, so that grouping works. What about a plus 3? Does that have something in common other than 1? No, it doesn't. So in that case, I'm going to choose to rearrange this. Now, technically, I want to be clear, you could work with it as it is, but it can get kind of confusing when the greatest common factor is 1. So we're going to rearrange to make sure that we have a greatest common factor other than 1. So I noticed right off the gate, hey, these 3's are going to have a greatest common factor right here. So that makes it kind of easy. I'm going to group those up. So if I group those up, then I've got a to the third and a that are going to be grouped up. So that and those have a greatest common factor, so that would make sense. So I'm going to go with a to the third. I'm going to move this positive a to second in line, which means my positive 3a squared is coming next, followed by my positive 3 at the end. Now you may be saying, well, you're not in descending exponent order anymore. You're right, I'm not, but we're grouping to get to factors, so that's not so important at this stage any longer. So now I can go in and I can group them, all right, remembering that the first term of the second grouping includes its sign, so we're not cutting that sign out, it's still a part of it. So now I need to factor out the greatest common factor of each grouping. So a to the third plus a, the thing that they have in common is just a single a. Now again, if it helps you to make the list, I'd encourage you to do that. So what did I multiply a by to get to a to the third? Well, that would be a squared. What did I multiply a by to get to a? Well, again, the only thing I can do for that is multiply it by 1. So again, there's my first one with the greatest common factor out. So if I have done this correctly, then I should end up with the same in the second. So again, what's the greatest common factor of the second one? Well, they don't both have a's, so it can't be a variable, but they do both have 3's. So I'm going to say positive 3 because my lead term is positive. Well, what did I multiply positive 3 by to get to positive 3a squared? Well, that would be a squared. Well, what did I multiply positive 3 by to get to positive 3? That would be positive 1. Now again, if I did this correctly, these should be the same, which they are. So there's my first parenthesis, so a squared plus 1. And my second parenthesis is what's left over, which is a plus 3. All right, well, another common question that I get on this is, does it matter which parenthesis comes first? No, it doesn't actually matter which parenthesis comes first, right? It just makes sure that your parentheses are correct, and then we always want our parentheses to be in descending exponent order. That just seems to make things go a lot smoother. All right, well, example D, I'd encourage you to try that on your own, then check your answer with mine. So example D, going to check my groupings, make sure that they've got a greatest common factor. So y squared plus 2x, I don't see a greatest common factor there. So I already say, all right, I'm going to go ahead and rearrange. Now I could choose to rearrange a few different ways, but the thing that stood out to me right away when I looked at this problem were there's 2's on both of these terms. So I'm going to choose to group those together, which means that I'm going to group these two together, which have a y in common, so we're good there. So I'm going to rearrange, leaving my y squared first, bringing my positive yx up next, moving my positive 2x to the third in this spot, and then my positive 2y is going to stay at the end. Now once I've rearranged, I should have put it in order where I can group them up. So I'm going to group them up. Again, remembering to put the sign with the first term there, right? So now what's my greatest common factor of y squared plus yx? Well, the thing that they have in common is y. So I'm going to factor out a y. What did I multiply y by to get to y squared? Well, that would just be y. What did I multiply y by to get to positive yx? Well, that would just be positive x. Then, what is my greatest common factor of positive 2x and positive 2y? Well, they both have variables, but they're different. But again, I saw that these both had 2's, so I'm going to factor out a positive 2. So what did I multiply positive 2 by? Goodness. To get to positive 2x, well, that is x. What did I multiply positive 2 by to get to positive 2y? Well, that would be positive y. Now again, if I did this correctly, my two parentheses should be the same, which kind of is similar to b in terms of they don't look exactly the same. This one is y plus x, and this one is x plus y. But again, remembering that as long as the order, if we could rearrange them and get the same order and it would make sense, then it's correct. Or if we plugged the numbers in, would we still get the same answer when we simplify? And we would. Y plus x is the exact same as x plus y. So I'm going to just rewrite this then as x plus y for my first parenthesis. And then my second parenthesis is going to be what's ever left over. So in this case, y plus 2. All right, well, if you have any additional questions on the grouping method, please let me know. But otherwise, you should have what you need to complete worksheet number 3 in chapter 6.